All right, so last time we were in here, we talked about we are going to investigate how two equations are equivalent. All right, so in this first activity, we saw that I assigned each one of y'all one of these expressions, and then we found out all of them ended up having the same solution. All right, so what did that mean? Because all of them ended up having the same solution. What did that tell us about these two equations?
That there was equivalent.
They were equivalent. All right, so a characteristic of something being equivalent is the fact that they have the same solution. So that's what we talked about with that activity. Okay, so we're going to go ahead and just keep moving through. So on 6.2, it says write as many equations as possible that could represent the relationship between the ages of the two children in each family described. Be prepared to explain what each part of your equation represents. So remember this little last sentence right here? That just means we have to define our variables. Okay, so let's look at it. It says in family A, we have the youngest child is 7 years younger than the oldest, and the oldest is 18. Okay, so if all of that is true, let's write as many equations as possible to represent that relationship. So who could tell me one equation that would represent the youngest child is 7 years younger than the oldest, who is 18? What would one equation be?
18 minus 7.
Okay, so Braden said one equation could be 18 minus 7, and what would that equal?
That would equal 11.
Okay, so what are you saying, that 11 is the age of the youngest child?
That is exactly what I'm saying.
Okay, age of youngest child. Good, there's one. What's another one? What's another way we could write that? Because it wants to know as many equations as possible.
You could do 11 plus 7 equals 18.
Okay, we could do 11, which we said is the age of the youngest, plus their 7-year difference is going to tell us the age of the oldest child. Good.
Maybe y plus o equals total.
You said y plus what?
O equals total.
Y plus what, though?
O.
Oh, okay, I get it. Okay. I thought you were just saying, like, I don't know what I thought you were saying. Okay, so you're saying Y is the youngest,
Yes.
O is the oldest, and then it tells us their total ages together, or it tells us their combined age, so it wouldn't be 18. Wait. The youngest plus the oldest would tell us their what?
Total.
It would tell us the total. Okay, that is true, but that really doesn't show anything about their 7-year age difference. Okay?
Yeah, it does. We're saying that their 7 years age difference equals the oldest.
The oldest is 18.
Right. And then you do the youngest plus the age difference, and that equals 18, the oldest.
You would have to do the youngest plus 7 would equal 18. Not the youngest plus the oldest. This one would be another one. The youngest plus 7 equals 18. If you put the youngest plus the oldest, it would give you their total age difference, or it would give you their total age combined, but that isn't what this particular question is talking about. It just wants equations that represent this relationship.
Then we win.
Okay, good. So what you just did was we found all of these different equations that are going to end up giving us the same solution. Each time we're going to solve it, it's going to tell us that the age of the youngest child is 11. Okay, all we did was arrange the equation. All right, now let's look at B. It says in family B, the middle child is 5 years older than the youngest child. Now this one is a little different than the last one because, do I have multiple people unmuted? Because I feel echoey. All right, so it says the middle child is 5 years older than the youngest child. So unlike the part A, where A told you one of the values, in this one we have two unknown values. So what do we use in place of values that we don't know they're?
A variable.
We use a variable. So what would make sense as a variable for the middle child?
MC.
We could just do one variable, M.
M.
All right, and what would be one for the youngest?
Y.
Good. Okay, so the middle child is 5 years older than the youngest child. So how could we find the age of them? What is an equation that we could do?
M plus Y equals O.
You're close.
M. M plus 5.
M minus, okay, so I heard M minus Y. So the age of the middle minus the age of the youngest is going to tell us what?
Total.
That it's 5 years. Okay? Because there's a 5-year difference between the two. Okay, there's one equation. What's another one?
M minus 5.
5 equals M plus Y. No.
That's the same thing.
All right, one at a time. I heard M minus 5 equals
Y.
Y. Good.
I'm gonna do.
Okay, so look, I want y'all to notice we have one that's set equal to 5. We have one that's set equal to Y. What's the only one we don't have it set equal to yet?
M.
M. So how could we rearrange it?
Y plus 5 equals M.
Good. Y plus 5 equals M. The age of the youngest plus 5 years is the age of the oldest, or the middle, I'm sorry. All right, good. So once again, you're seeing that these are all just equations that are rearranged. Now I want you to really focus on this next one, okay? So that I want you to make this connection. It says, Tyler thinks that the relationship between the ages of the children in family B, okay, so we're looking at this family right here, the one we just did, can be described using this equation. 2M minus 2Y equals 10. Where M is the age of the middle child and Y is the age of the youngest, just like we said earlier. All right, so explain why Tyler is right. Okay, so we came up with all three of these equations right here to represent that situation. Tyler came up with this one and he is correct. Okay, so I'm going to give y'all about a minute. I want y'all to look over that and I want you to come up with a reason why Tyler's equation is also correct, just like ours are. Okay, don't tell me yet. Don't shout it out. Wait till the timer is off. Ready? Go. So someone tell me, why do you think that these this equation that Tyler came up with is correct?
Because they are both equivalent.
Okay, how do you know that they're both equivalent?
Because it uses the same numbers.
Okay, I didn't use any 2s and 10s up here in part B. What do you mean they use the same numbers?
Well, they use the same like variables.
Okay, he did use the same variables because we're talking about the same situation. But
Right.
what exactly did Tyler do to it? Do y'all notice what he did? Because
He
this
just-
equation looks very similar to this one.
Oh, he just moved the variables by the numbers. Or I don't know.
Okay, so up here in mine, I didn't use 2, 2, or 10. We didn't have any coefficients, and I used 5. So what did Tyler do to his equation?
You doubled it.
He doubled the equation. Okay, so look, write this down. Tyler multiplied everything by 2. All right, so because Tyler multiplied everything by 2, it is still equivalent. It is still right, like Joseph said.
I knew I was right somewhere.
All right, so did anybody else, whoops, didn't mean to write a 3. Did anybody else think of it differently and understand how Tyler came up with it?
Well, 1 plus 2 is
Do what?
one plus
Whoever's talking is just glitching.
two is what?
We can't. You're like, well,
No,
I don't know. I don't know.
Okay,
it's confusing.
so this is the way I kind of thought of it. The way, this first way is one way you could have told that it is equivalent. You could have just saw that they took this equation right here that we came up with in B, and they just doubled it. They multiplied everything by 2. Another thing is that we know that the age difference was 5 years. So I could have just came up with ages that were 5 years apart. I could have said the middle child was 12, which meant the youngest child was 7, right? Is that a 5-year age difference?
Good.
Okay, now in order to tell that it's equivalent, I would have to plug it in and see if I got the same solution. So let's try that. I have 2, and for M, what am I gonna substitute?
The total.
The 12 minus 2. What am I gonna substitute for Y? 7. And if it is equivalent, it should all equal 10. Okay, so let's simplify. What's 2 times 12?
24.
All right, what's 2 times 7?
14.
14. So I have 24 minus 14. What's 24 minus 14?
10. No way.
10. Does 10 equal 10?
Good.
Yes. So if we substitute values for M and Y, get the same solution. All right, so there's 2 different ways you could have thought about that. So whichever one makes more sense to you, just go with that way. Okay, if it makes sense to you that we can substitute in and we'll get the same solution, so that makes them equivalent, then you do that. If you notice that they took this equation right here and they just doubled it, then that's how it's equivalent, then you go that way. All right, give me a thumbs up if we're ready to move on to the next part. See some people still writing. That's fine. Okay, let's look at it. All right, so keep these two things in mind right here. The fact that we multiplied everything by 2 and that you can use substitution to see. It says, are these equations equivalent to one another? If so, which ones explain your reasoning? So how do we determine if things are equivalent? They have to have what?
Their equations,
Do what?
they have to equal the same.
They have to have the same.
No, you know what I mean.
Yeah, I know what you mean. They have to have the same solution. All right, so how are we going to determine if this equation, this one, and this one have the same solution?
Substitute numbers.
Well, we don't have any numbers to substitute, so what do we have to do?
Make variables.
Get the variables by themselves.
Get the variables by itself. Okay, so I'm going to give y'all about 2 minutes. I want you to solve those, and I want you to determine if any of those 4 equations are equivalent. And if so, send it to me in the chat when you finish. All right, I'm going to give you about 2 minutes. Ready, go. Okay, so if I have to determine their solutions, how am I going to do that with number 1? What am I going to do?
Subtract.
This,
I'm going to
this-
subtract 6
15.
from 15. Good. What happens to my 6s?
It cancels out.
It's gone.
Out. And then I have 15 minus 6. What does that equal?
9.
Whoa, that looks really familiar.
Oh, that's so cool.
I didn't do that. I just worked it out in my head.
Are those 2 equivalent at least?
They are.
They are.
You're so smart, Mr. B.
Ball out.
All right, so then we have 3 times a. So how am I going to get that a by itself?
Divided by 3.
Divided by 3. They cancel. And a equals,
I said
all right, since this was the same thing as that, we know that a equals what?
3. See, I got all of them right.
Shut up.
Alex, did you get all of them right?
Of course I can all of them right. It's just
All right, we have a plus 2 equals 5. How am I going to solve for a?
You gotta get the largest variable or the farthest number. I don't know. I figured it out somehow.
I'm going to have
Subtract.
to subtract 2.
And if you subtract 2, the 2 cancels out, and then you get 3 on the other one. And then, oh, A equals 3. Did you see what I just did there?
Hog Miss Frisbee. Right, you're not playing.
No.
Okay, and finally we have 1/3 times a. How am I going to get that by itself?
Multiply it by 3.
Yeah, you would multiply by both sides by 3. Those cancel. A equals 3.
You confused me. I was like, why is she thinking?
All right. Let's zoom out. All right, and then finally we have a equals 3. They all have the same solution. Therefore, we know they are what?
Good one.
They are equivalent. Yes. They are equivalent. Y'all write this down. Because they all have the same solution. Hey guys, I have to take a call really quickly, so we're going to go ahead and take our break now, and then we'll come back to this in just a second, okay? Noah is buying a pair of jeans and using a coupon for 10% off.
Where are we on 6.3?
All right, the total price that he ends up spending is $56.70, which already includes the $2.70 sales tax. His purchase can be modeled by this equation. All right, they already do the hard work for us. Okay, so this represents the coupon. This represents the tax. And this represents the total he spent. Okay, so let's look at number 1. It says, what does the solution to this equation mean in this situation? So if we were trying to find the solution, what would we be finding?
The answer.
The answer, the x value. Okay, so what is that x value going to tell us?
The answer.
It's going to tell us the answer, but what does it mean in this situation?
The solution.
That's the answer. How much the price is?
Total price.
No, we already have the total price. Destiny, you were close. What were you saying?
How much the price is of the jeans?
Good. The original
Oh, shoot.
price of the jeans. So you know, like when you look on the tag of a pair of jeans and it's like $59.99. I don't know. That's a really expensive pair of jeans. And then you end up going and paying for them, and you end up spending a different amount than what was on the tag.
That's
That's what X represents in this situation. Is that tag price before you apply a coupon, before sales tax, and all that jazz. All right, for B, it says, how can you verify that 70 is not a solution and 60 is a solution? How do we determine if something is or is not a solution?
We have to, like, answer the equation.
Okay, what's that called? What do you mean answer the equation?
Find the solution. Solve the equation.
We have to solve the equation, so we know that we can solve it for x equals 70 and x equals 60. So how are we going to determine if it is or is not a solution?
Substitute.
We're going to substitute it, okay? So it doesn't ask us to prove that it is or isn't. It just asks how would we know. So we could just say we could substitute them into the equation and determine what makes the equation true. Okay, so we know that X, we kind of broke down our equation, what all the different parts mean. The 0.1 is that 10% coupon. The 270 is our sales tax, and then the 5670 represents the total we spent, whereas the X represents the price of the original jeans. Okay, so we're going to need to remember that equation as we move forward in this problem. So it says for number 2, here are some equations that are related back to 5670. It says they are related. Each equation is a result of performing one or more moves on that original equation. It can also be interpreted in terms of known as purchase. It says, for each equation, determine either what move was made or how the equation could be interpreted. Then if 60 is the solution of the equation. Okay, so we determined earlier that 60 was the solution because they substituted it in. So how are we going to determine if 60 is the solution for all new equations? How are we going to determine if 60 is the solution? Substitute. All right, I need more. There's multiple people unmuted. I need only one person to be unmuted. Okay, so I'm going to do A so you can see what I'm wanting. Okay, so we have this equation right here. It wants us to determine how similar to here. So what was done to it? How is this equation similar to this one that we just looked at?
The X has a 100 in front of it.
The X has 100 in front of it.
The one is really different.
They're all multiplied by 10.
Close, not 10. This was a 1, now it's a 1.
Yeah, no, I'm trying to tell you.
I don't understand.
I'll check on you.
Should I like yours?
I can't hear what you're saying.
Can you hear me?
100.
Okay,
100.
write this down. Everything was multiplied by 100. I don't know if I spelled that right, but yeah. Everything was multiplied by 100. Okay, now it wants to know, I don't care about the interpretation of any of these. You can just mark that out. It wants to know, is it the same solution? How did we say we were going to determine if it was the same solution?
Substitute.
Substitute. So we said the solution that X equaled 60. Okay, so we want to know if 60 is still the solution. So let's write down our new equation. 100x minus 100, or I'm sorry, minus 10x plus 270 equals 5,670. Okay, so I'm going to substitute in my x equals 60. So I'm going to bring down my 100, but instead of x, I'm going to put what?
60.
60. And then I'm going to write down 10, but instead of x, I'm going to write down
60.
and then do plus 270 equals 5,670.
But
Okay, so let's simplify this. What's 100 times 60?
6,000.
Good. What's 10 times 60?
600.
Okay. What's 6,000 minus 600?
5,400.
Good. All right, what's 5,400 plus 270?
5,670.
All right, so is it still the solution? Is 60 still the solution?
Yes.
Yes, because my equation is still true. So right here, you would just put yes. Okay, so here's what you're gonna do. I'm gonna split y'all up so this doesn't take too long. So what I'm gonna have y'all do is I'm gonna give you the number 1 or 2. If you get number 1, listen, if you get number 1, you're gonna do equation B and C. If you get number 2, you're gonna do the same thing we just did for D and E. All right, so listen close. Here's what you are getting. All right, so it says what was done. So if you have equation B,
Oh,
you need to be writing down.
can I say it?
Yeah, Braden, what was done to the equation?
The solution was subtracted by the 270.
It literally says it on the paper.
Do you not know what I'm trying to, go against it?
Subtract 270 from both sides of the equation.
Good. Now I want y'all to focus in that they subtracted 270 from both sides of the equation. So underline or highlight the fact that they did it to both sides of the equation. All right, I did not care about the interpretation, but did it end up having the same solution? Did x still equal 60?
It did.
It had the same solution. All right. All right, for D, for this equation right here, someone explain to me what was done to it.
10% of anything, 90% of the original price.
Say it one more time, Alex.
90% of the original price plus sales tax.
Okay. So this time I noticed there's only one x in my equation. So what did they do with the other one?
It gone.
They merged it.
They didn't just get rid of it. What did they do?
They
Threw it
made
away.
A number.
The original equation was 1x minus 0.1x plus 270 equals 56.70.
They gone it.
They what?
They unaligned it. It's not there.
Okay, but we can't just get rid of, we can't just take it out. What did they do?
They did that right there.
Just,
What you highlighted, they did that and it equals 0.9.
Okay, so they did 1 minus 0.1. What's 1 minus 0.1?
1.
0.9. So what did they do?
Combine like terms.
Good. They combine like terms. Right, did it end up having the same solution?
yes.
Yes, it did have the same solution. Okay, so here's what I want you to notice before we move on. So far, when we just combined like terms, we didn't change anything about our equation, or we did something to both sides. We did something to everything in the equation. Did my solution stay the same every time?
Yes.
All right, so let's look at number 3. So this was the second group. It says here are some other equations. For each equation, determine the next stuff. So for D, what was done to this equation? What did they do to this equation?
The price after using the coupon for 10% off and before sales tax.
Okay, that's the interpretation, but I want to know what they did to this original equation. Remember, my original equation was this.
They took 2.70 out.
Mr. Frisbee, I don't understand any of this, so, yeah.
All right, so in this equation, they subtracted 270 from one side, but did they do it to the other side? That would cause them to cancel out, but did they add it back on over here or subtract it back over there?
No.
Did they?
No.
No, they didn't. Okay, so
I'll look away for 1 second. Like, there's like a whole equation.
they subtracted 270 from one side. All right, so when they only subtracted 270 from one side, did we end up with the same solution?
No.
No.
No. Okay, so let's see if we notice a pattern. When we did the same thing to both sides, we got the same solution. When we did not do the same thing to both sides, did we get the same solution?
No.
No. Interesting.
Oh, sorry.
Okay, now this one was already done for you. It said we subtracted 270 from the left, but we added 270 on the right. Okay, so did they do the same thing to both sides?
Yes, so it's gonna be the same.
No, they subtracted 270 on one side and they added 270 on the other. So is it gonna have the same solution?
No.
No. Okay, let's do this last one together. Now, everything looks the same about this equation. All of that looks the same. All of this looks the same. The only thing I noticed is that they did this on right there. Okay, so what was done?
They made it where you have to distribute.
Okay, so we have to distribute a 2. So, oops, oh my gosh.
Sounds good.
They multiplied by 2. Did they do it on both sides or just one side?
One.
I watched Waterboy yesterday.
Awesome. All right, so since they did it on one side, is it going to have the same solution? No, it is not going to have the same solution.
I swear to God, see the falls out one more time.
Jordan, when did you punch your computer?
Okay, so it says which of the 6 equations are equivalent? Well, what makes them equivalent if they have what?
If they do the same thing on both sides,
If we did the same thing on both sides or if we end up with the
same solution.
same solution. So which one of these are equivalent?
Okay, we got B, we got C, and we got A. A, B, C.
B.
Would fall on though.
All right, so it says be prepared to explain how you know. How do we know they are equivalent?
Because they have the same solution.
And Braden, you said the other one just a second ago. What was it?
But what?
You said this. You said the other reason a second ago. What was it?
We did them on both sides. That's it.
Okay.
Is that what I said?
Yep.
And Ms. Frisbee, I got a question.
Yes, sir.
So if we made a D for a semester, like let's say I made a D on my semester grade, would that mean I'm held back?
Yeah.
No.
All right, so it has to be like a F, right?
Correct.
All right.
You'll just get RTO next year.
No, you'll be held back if you fail.
Ms. Frisbee just said the D is not failed.
Just in this class.
He said, not if
You
you
just
fail,
had-
like, he's saying,
That's what I'm saying.
For only a,
he's saying
for
if
only.
it's like a D, he's gonna have to have RTO, and he's not gonna fail.
The RTI is on your, what's it called, score, isn't it?
Transcript? GPA?
Your,
Your dumb level?
Okay, let's look at the lesson summary.
as far as
All right, what page is the lesson summary on?
180.
I said first.
Is this our only lesson for today?
I'll think about it. All right, so we have a situation right here in this first paragraph. Suppose we bought 2 packs of markers and a 50-cent glue stick, and we ended up spending $6.10. P stands for 1 pack of markers. And they give us this equation right here. So 2 packs of markers, 50 cents for the glue stick, and our total price. And then it tells us the solution, bless me, is 280.
watch yourself.
What I do?
That's Skylar is ready.
All right, next, we have another situation. Now we're gonna buy 6 of the same packs of markers and 3 glue sticks. And we're gonna pay $18.30. And this is our equation. All right, 6 stands for how many packs we're gonna get. $1.50 is how much we'll spend on glue. And then 1830 represents the total we purchased. The solution to this equation is also 280. Interesting.
They're equivalent.
Incorrect.
All right, so it says we can say that this equation and this equation are equivalent equations.
What did I say?
Why are they equivalent equations? Because they have exactly the same solution. All right, it says besides 280, no other values of P make the either equation true. Only the price of 280 per pack of markers satisfies the constraint in each purchase. So how can we just tell any other way that they are equivalent? So this is our first equation and this is our second. Can y'all see anything that was done to the first to get the second one?
Addition.
I mean, yeah, we could get the second one by adding it, but we have to do the same thing each time. So it says in this example, the second equation, 6P plus 150 equals 1830, is a result of multiplying each side of the first equation by 3. Multiplying each side by 3. Okay, so if we took this at first equation and multiplied both sides by 3, that would equal this equation. Okay, so that's another way to see that they are equivalent. You just took the first one and multiplied it. So if we are buying 3 times as many markers and glue sticks, that means we're paying 3 times as much money. So the unit price did not change. It says here are some other equations that are equivalent to this equation, along with the moves that led to them. All right, so the first one here, what they did was they added 350 to each side. Each side is that key word right there. If they do the same operation to both sides, it's gonna stay equivalent. Okay, what about in this second one, what does it say they did?
Subtracted 0.50 from each side.
Good. They subtracted 50 cents from each side. All right. And for 3, what did they do?
Multiplied each side.
Multiplied each side by 1/2. And then finally, they performed the distributive property on that last one. Just a way to rewrite the equation. Okay. So the move is acceptable because it doesn't change the equality of the 2 sides of the equation. Okay, because they're doing it to both sides, it's going to essentially stay the same. It's just going to look different. Okay, which is what we've talked about a lot, that's what equivalent means. All right. These moves, applying the distributive property, adding the same amount to both sides, dividing each side by the same number, and so on, might be familiar because we have performed them when solving equations. Solving an equation is essentially writing a series of equivalent equations that eventually isolate the variable. However, not all moves that we make on an equation could create equivalent equations. And we talked about this. If we subtract 50 cents from the left side, but we add 50 cents to the right side, the results are not going to be the same because we did not do the same thing to both sides. They're not going to be equivalent.